Cool. First, I'll be talking about a little bit about rocket science, which is mostly in applied physics, the hypersonics of single stage to orbit. So before I get into that, I'd like to talk about a few things I learned in scientific research this year. One, failing isn't really much fun. Two, you can only understand what Jason Saroni says if one, you're Mr. Adeleye, or two, you understand that a great part of understanding stuff is all in the nod. So no matter what he's saying, just go ahead and nod with him. You're actually going to understand. And three, if Mr. Escada says you should do a review paper, do not think you're a genius and try to do your own experiments, because you'll end up failing and not having a paper to write at 2 nights before submission, which is what mostly happened to me. And so I'm going to supersonics. So before I talk about what I want to go into tonight, which is mostly just a short expose, I'd like to give you a slight background on supersonics themselves. Supersonics deals with flying faster than sound. Sound travels at about 1,200 kilometers per hour in air at sea level. And the first supersonic flight was made in 1947 by the US pilot Chuck Yeager. And supersonic regimes, you keep on going faster than sound on and on in multiples. But by the time you get to 5 times faster than sound, you get into the hypersonic regime. Which means that at this point, most of the normal physics you know with aerodynamics breaks down. There was a need to come up with an aerothermodynamic theory to deal with that. And there's also a lot of change in design, engine structure. Basically, people had to think in a different way, because it was not dealing with aircrafts traveling through air anymore. It's like aircraft traveling through a chemical layer or something like that. And so this is just a picture of a cool fighter. It's an F-15 about to break through the sound barrier. And okay, to explain most of what I'm doing tonight, I'll use these 2 aircraft. This is the SR-71A Blackbird. It was made by the USA in 1962. And it's a reconnaissance aircraft. They used it to spy on the former Soviet Union a lot. It could cruise at 3.2 times the speed of sound. So basically what that meant was, if you were to travel from South Africa to Morocco on an SR, it would take you 2 hours. And, but the thing was that by 1989, the USA scrapped the program. The only functional ones are at NASA's facility at Houston. And many people like me who are into aircraft, and also Mr. Parks, believe that there was no way the US would scrap something this good if they didn't have a replacement. And by the early 2000s, some journalists and other people started to spot another aircraft, a strange craft, which flew faster than anything any human being had ever seen before. And most people believe that that was the Aurora. Part of it was in the WikiLeaks scandal. And it was part of what led to the US agreeing to Area 51 actually existing. So it's a black ops project, which means the US government is not ready to agree that it exists, amongst other things. And it's the borderline for understanding what hypersonics, present-day hypersonics is. So most times when you think about hypersonic theory, when you look at these 2 crafts, what comes to your mind is that they're both for military purposes. So people think this is only for war machines. This is not necessary for our time. But then there's also an important aspect to hypersonics which most people don't see, which is single stage to orbit. So what you see there is the Apollo Saturn V vehicle. That was Apollo 11, 1969. Neil Armstrong went to the moon. And this is Space Shuttle Columbia OV-102. So what they're doing here is staging. They have different rocket stages that have to be did to reduce the mass to let it get up to the escape velocity they need. So what single stage to orbit is trying to come up with a way to get a vehicle that can get to space in one stage. From the ground, lift up like an aircraft, and you get into space. And the ramifications of this are enormous, because that means that we'll be able to have cheap, affordable commercial spacecraft for regular human beings. It would be one of the best ways to be able to, if you want to think about creating the crazy things that Kiribel thinks of for his scientific research, because it have to be built in space, they can't be built here and stuff like that. And in order to deal with this, there's 3 major things you have to account for. The aerodynamics of the aircraft, because there's special aerodynamic theories, they're mostly called aerothermodynamics in this field, when they're trying to create hypersonic vehicles. There's the body framework, what it's made of, and this is actually one that's really interesting to me, because this innovation was developed by a lady. She's a professor at MIT. Her name is Dava Newman. And she came up with these ceramics called ultra-high temperature ceramic composites, which can withstand extensive heats. You'll appreciate this when you come to think that a hypersonic craft could be heated up to 1400 degrees Celsius. You can't touch that. But then, what she did was that with these materials which she came up with, you could actually heat one side of it up to 2000 degrees, and you touch the other side, and it would still feel at room temperature while the other is white hot. And finally, you also have to deal with the propulsion system. You can't use regular jet engines for this. Most of the propulsion systems for this are prototypes. They're very experimental. This is the principle of scramjet propulsion, which uses supersonic air that's compressed to use Newton's third law to get things flying. And this is the principle of the aerospike engine, which, unlike a normal engine that has a bell nozzle, just releases the gases into the air and uses the varying pressures in the air around the engine to create a virtual bell out of air. And yeah, that's mostly it. So, as I'm going to, this is what I'll be doing in college still. I hope I don't fail as much as before, because then my GPA would suffer a lot. But then, I would like, with the blogs, these are some of the questions I hope to pursue in college. But before I end, there's something I actually read up. It was by a physicist called Prandtl Grant in I think 1953. And not just aircraft go supersonic. Things as simple as a bullwhip can go supersonic. And there's this belief that if a human being can spin, actually get up. So let's change this. Okay, so try to spin on this, give yourself space so you don't hit each other. Try to spin on the spot, make 4 cycles in 1 second and see if it's possible. Just give it a try. Try to spin around 4 times in a second.
4 cycles in 1 second.
Okay. Okay, guys, it's good. The principle mostly states that if a body is able to complete 4 revolutions around its center of mass with a frequency that's about 16 hertz, it would actually be able to break a mini sound barrier, kind of thing. So you guys almost would have been able to go supersonic too. Thank you.